Welcome to solverfy.
So first, we know that the velocity of the satellite is going to be equal to the square root of the gravitational constant times the mass of the Earth divided by the distance between the satellite and the center of the Earth, r. This would be equal to 2 pi r over t. This would be based on a definition of velocity. In that based on a definition of velocity for an object in uniform circular motion. So we can say that the period of a near Earth orbit would be equal to 2 pi times r cubed divided by the gravitational constant times the mass of the Earth, quantity to the 1/2 power. And at this point, we can solve. So t will be equal to 2 pi, and then we can say square root. For the denominator, we'll have 6.67 times 10 to the negative 11th times the mass of the Earth, so 5.98 times 10 to the 24th kilograms. And then for the radius cubed, 6.38 times 10 to the 6th meters cubed. So we're using the radius of the Earth because we're trying to evaluate this for a near Earth orbit, which means that the distance from the satellite to the surface of the Earth is negligible compared to the distance from the surface of the Earth to the center of the Earth. And so we can say that after plugging this in, we find that the period of a near Earth orbit is going to be 5,070 seconds. And as you can see, the period is based on the mass of the Earth. However, it is not based on the mass of the satellite. So we can say that t, the period, is independent of satellite's mass. That is the end of the solution. Thank you for watching.